So F4 to find my page right here. Okay, so with this one here, you're doing dimension analysis. Dimension analysis is a way of uh, doing calculations. And when they call it dimensional analysis, you're using units. And it's kind of, I almost think it's kind of like, I don't play chess, but I've heard about chess and how it's played. It's kind of like a game. The units you have that they give you in the question directs your move. Okay? So it's like you read a question and the question gives you a number, a starting unit. And the starting unit is like your starting point. So you are aware this is how this game is played. This is how dimensional analysis is done. The given unit, so in this example here, let me see if I can write, draw. Yeah, the given unit, so they give you a number, but the number is not as important as the unit. The number is important, but the unit tells you what to do. So the given number and the unit is the starting point. So when you read a question, you're looking for that starting point. How do I start? Or where do I start? And the starting point usually goes with that unit, right? So in this one here, this is dimension analysis. They gave you a given 1 day. So you write out 1 day. This is the starting point. And then they have to tell you how far to go. That's the end point. Because you can, oh my goodness, you can write a long dimension analysis uh, process. So it's kind of like long division, only with long division, which I haven't done in a very long time. Say they tell you to divide 3 into 12, you do stuff. It's been a while since I've forgotten, I don't know. But yeah, you do the steps, right? And then you go through the steps until you get to the end and then you stop. But with this one here, once again, the given number and unit, especially the starting point, and then the end point tells you how far to go. Once you reach the end point, don't go beyond that because you're done. Okay? You have to judge your unit. What type of measurement do you have? Did they give you time measurement? So I gave you guys a document. I know I gave you guys a lot of stuff. You see how, I mean, I'm sure you've seen that I gave you guys a lot of stuff. Let me go over here so you can see. I gave you guys a document. For some reason, I'm not able to find it right now, but it's back here. And this, yeah, the metric conversion is very important. So I suggested to you that you probably want to, um, oh, this is metric conversion. Sorry, hold on a second. I'm trying to find the conversion table. That's not what I'm talking about. Something else. There's a conversion table somewhere here, maybe with the PowerPoints. Oh, there. The conversion table. You see this one right here? So in the lecture, I told you that it's good for you to actually download this and print it out. So actually, I would say download the conversion table, that one. Download the metric conversion. That will help you in your conversions. Okay. For right now, I just need the metric conversion. So I'm going to open that. Then, like you're doing, you can take a screenshot, but it's all available to you later on. Okay. So let me click. I'm showing this to you because you're seeing the types of measurements we have, the classes. Some of them are lengths, some are mass, some are volume. What they don't have here is some of the measurements are time measurements. So you kind of want to know, they don't have time conversions or equality here because they assume everybody knows time, right? So time was not included here. But just in case you're missing time, you can find the conversions online. Okay. So I'm gonna have this here. Let me go ahead and find I know I have all these pages open because the way this works is I need all these pages. The fun of chemistry. Right. Hold on. Right. So as we're working on this, hold on a second. I have my conversion table right here. Now, oh, the lab is what I needed. That was this right here. This, and then where did the lab go? Right here. Hold on. I'll just download it here again. I have so many pages open. Right. So once we have this here, I recognize, oh, from the list, this is a time conversion. So the time conversion, we need one that has day in it. And there's so many different ones for day. So this one here, you have to go from your experience, right? They give you this starting point, this end point. You can say 1 day, as you know, equal 24 hours. You can say 1 week equal how many? 7 days. So these are different equalities. These are called equalities because it's the same amount of time measured in two different units. One of them is day, the other one in hours. This one here is week, and then the other one is day. Just showing you here that these equalities, like the one I showed you in the table, can be converted to conversion factors. So once we are here, now we see we need to use, based on this here, your move is to find a conversion factor that has day in it. Okay, this has day, this has day, but it has to be one that you pick that's helping you get to your desired unit. Here we're going from a bigger measurement or a bigger unit, day, to seconds. Seconds are very small, so this may not be the best one to choose. The next best one to pick is this one here, 1 day, 24 hours. So we normally write this with the conversion brackets. I'm going to draw them right here. 1 day. The conversion bracket looks more like this. I prefer the brackets than to just write it like that. So the unit you have on the top left has to match diagonally on the bottom, the unit on the right. So you got 1 day here. Whatever this number here is on the bottom, it has to have the unit day so that this conversion can work. So we can actually do dimension analysis. Okay? So this has to match that. For that reason, I'm going to write this number that goes with this unit, 1 day down here, and up here, 24 hours. They go together like a combo. Okay? I cancel this and this, but I'm not done. I'm now at 24 hours. At 24 hours, the next move is you need to find a conversion with hours in it because we have to keep going until we get to seconds. There's no seconds right now. So I remember, 1 hour, all right, like this, 1 hour is 60 minutes. I don't want to use your conversion. I don't memorize this. 1 hour is equal to 60 minutes, right? So I'll use that. 1 hour goes with 60 minutes. But I can't stop yet because this unit here is minutes. They said I have to go until seconds. So I cancel hour and hour. One more conversion. 1 minute is 60 seconds. So once again, if you don't have these time conversions here, you can find them online, include them in your sheet of paper so you can know which ones to pull out. And I have here 1 minute is 60 seconds. Give me just a moment. Let me grab a water right here. Okay. So you see how we have it, right? Now cancel the minute and the minute, and then your answer will now end up being in seconds. So to do your math, multiply all the numbers on top, divide by the numbers on the bottom, and that gives you your answer. So we should get the exact same number, even though our process was slightly different. Okay. So as far as
multiply the numbers on top.
right, so it would be 24. I mean, you can include the 1 if you want. 1 times 24 times 60 times 60. And then if you have like non-1 numbers, divide by the bottom numbers. Divide by 1, divide by 1, divide by 1. Divide by all the bottom numbers to get the answer that you're trying to get.
Okay.
Yeah, divide all the bottom numbers, and that will give you the answer. So now in the actual the purpose of the experiment is to become familiar with using dimensional analysis to perform conversions.
Units.
Right, of different units. So you're going to be coming up with your own equalities. You see how we had these here, these equalities? You're coming up with your own. So let me walk you through just one, okay? In this first one, you are going to come up with your own equality that's going to convert inches to centimeters. Now, the handout I gave you has some equalities, but you're coming up with your own. To tell you here, what you need is a ruler, graduated in inches and centimeters. So find a ruler where one side is inches and the other side is centimeters. Okay, so just a regular ruler you can find from Walmart, dollar store if you don't have one at home. Then it says right here,
Okay.
find a rod. You can use a pen, a pencil here. Either one is fine. I say a pencil. Just something that has that kind of shape, like a rod. Pencil will work. Then it says place the rod, pencil, on a flat surface and measure its length in inches. Then you write the length of the pencil right here in inches. Make sure you estimate if you have to estimate, right? Record it in inches. Then place the
Okay.
same rod, same pencil. I should have written this to the end. This is pencil. On a flat surface and then measure its length in centimeters. Same rod, same pencil. And record the length right here. Okay?
What's the difference between the first one and the? Oh, never mind. I see
The
it.
unit.
Centimeters and inches. Okay.
Right. That's the
Yeah.
whole point of dimension analysis. Right. It's the
Okay.
same. The whole point of the equality is you're measuring the same thing, but you're doing it in different units. So you're doing the same thing, but in different units. You're kind of practicing how they got these,
Yes.
but you're doing it for different ones. Right. So where was I? Yeah. And then it says, set the results from step 1 and 2 equal to one another and calculate the number of centimeters in an inch. So whatever number you got here, you write it down here. Whatever number you got here, you write it down here because you see it goes with centimeters. This one here goes with inches. Okay?
Okay.
Yeah, so I'm going to make up some numbers. Say you got 10 inches equal 100 centimeters. They said, okay, now that you have this, they say calculate the number of centimeters in 1 inch. Since you have this here, you will then use this here to figure out the centimeters in 1 inch. So this is 1 inch. So you write 1 inch, and then you use these like they were an equality. You put this 10 down here, 10 inches, 100 centimeters, and then take this, divide by that, right? You take 100 divided by the bottom number, 10, and you get 10 centimeters. So here for the number, you put 10. And so for you, you got 1 inch equal 10
Okay.
centimeters. Okay. Now I made up these numbers. These are not actual numbers. So you will write this based on your experiment.
Yeah.
You do the same thing for the
Okay.
second one. You need to have a balance to weigh in grams. You want to same object. The object here and the object here are the same. And you want to get grams to ounces. So I have a scale that I use to weigh my food sometimes and stuff. So I just change it from the same object sitting right there. I flip it from one menu to another, from grams to ounces, and I weigh it. Okay. What is this one? Oh, this doesn't belong here. This is for talking about the first one.
Which one?
This any object of known length is suitable. This is referring to the rod all the way up here. I don't know how it moved down there. The rod right here, the comment is saying any object
Any
of,
object is length.
right. Okay, and then for number 3, you would do, oh, same thing. You want to find the grams in 1 ounce. Same thing. You put your numbers, whatever number you got here in ounces, you write down here. Whatever number you got in grams, you write down here. Then figure out how many grams you have in 1 ounce based on what you did, the math. And you have one more step. This one here is saying you want to have an empty plastic jug, milk jug, with half-gallon capacity. Doesn't I don't think it has to necessarily be a milk jug. It can be a water jug, just anything. You don't have to go buy milk. Just it can be one of those water jugs with half gallon capacity. Then it says here 100 milliliters graduated cylinder and a quart measurement for measuring cup. I have the measuring cup, the cooking cup, for the ones that you use for cooking, the glass one. I have those and I have the ones that are, the different ones. So I just use that. This one here will be in your kit. This one here, I think that may be in the kitchen. Okay. So once it says fill the empty milk jug or the water thing with water and empty it into a quart measuring cup. If you have a measuring cup, one of those measuring cups in the kitchen that look like glass cup or something like that, that measures quart, it can be your water bottle. If you have a water bottle that has a little graduation, just empty the jug into the quart measurement. So it has to be some kind of container that measures quart. Okay, and you want to write the volume of that water, same amount of volume in here in quarts. Then pour the same amount, or I guess they're saying here, fill the empty milk jug with water and then empty that. So the idea is the same amount of liquid that was measured in quarts will be measured in liters. Okay, and like before, the quarts number goes
Okay.
here, the liters number goes here. See, it's not that bad, right?
Yeah. No.
Sometimes
Mm-mm.
it's just feeling lost. It's because it's
It's
new
just
to you.
knowing how to Yeah.
Right,
Yeah,
it's new.
for sure.
So I'm not gonna work these
For
out because these
sure.
are the actual questions, but I'm gonna work something similar. So I'm gonna make up some questions and then we're gonna work those out. So let me see. Yeah, because this is the one that I want you to work out. I'm gonna work on something similar to this. So where is my conversion chart? It should be somewhere here. There. So what I'm gonna do is I'll do let's see, what do we have here? We have a mass conversion. So what I'm gonna do, let me make up some numbers. Give me just a moment. I'll use your course number
Okay.
and then we'll do mm, okay. And then the next one would be and this would be no, let me do this is gonna be kilograms. Okay. And then let's see, 2000, this is pounds. I'm trying to do different conversions. This is a quarts. For gallons to okay. Okay, hold on. Let me see what the units are. Okay, so I got these numbers. What I'm gonna do here in this, let me see, can they allow me to add a page? Okay, do they allow me to add a page here? Let me
No,
see. Oh,
no,
yeah.
no, no, no. Sit.
Oh,
Sit. Sit.
I was about to say what?
Sit. Oh,
Okay,
my dog is being weird.
okay.
What do you want?
Okay, so I came up with some numbers. I just made them up. The first one's gonna be 1405, like the course number of this class. So we're gonna do 14. Okay, let's see. Can you hear? Can you hear? Can you see what I'm writing? I'm trying to move my mouse. 1405. That's the first one. We're going from centimeters to yards. Okay. So I'm gonna take a step back a little bit, and you're gonna tell me what to do. So what type of measurements, what group of measurements is this? Centimeter to yards. What do you think? Is it length, mass, volume, or
Um,
time?
length.
Okay, so we're gonna look here in the length region, right? And hopefully you can see my whole screen. So what conversion do you think we can
Mhm.
use to go from centimeter to yards? What's the best one?
Let me see. I mean, I'm trying to pull up the metric one, see if it'll
Oh
pop
no, no,
up.
this the one I have on here is the best. The metric one will not take you to yards. Metric will
Oh,
be metric prefixes only, like centi, hecto, whatever. This is the best to go from metric to the standard one.
okay. Let me see.
So you tell me,
So
whatever
it
you
would
tell me, we'll
be
build it up from there. So which one do you think is the best conversion to pick? I'll tell you this. The best
mm,
one is one
the yard.
equality. Okay.
One
The
yard
best one is
equals
one equality that has both.
0.14.
Okay, so you want to go with this one? Okay. I'll write that here. You said you like 1 yard
Yes.
equal 0.914 meters. Okay, that looks good. Now the issue with this one here, it doesn't take you from yards to centimeters. It takes you from yards to meters. So it has this, but it doesn't have this. So we need another conversion that goes from meters to centimeters.
So it'd be a foot.
No, we need since we already got this yard and yard here, we need to map meters to centimeters. Oops, I went too far. We need to connect meters right here to centimeters. So you can't bring in a third one.
Mm-hmm.
Right. The way these equalities
Mm,
work, you're kind of connected. In the end, when you're doing dimension analysis, you have the units twice, right? So let me show it to you like this. You see how yards appears here? Yards appears here. We need
mm-hmm.
another equality that will make meters appear twice and centimeters appear twice. That's what I'm telling you. Find another equality on here in the length section that has meters and centimeters to make them both appear twice.
So it'd be a 1 centimeter equals 10.
Okay, this is millimeter. So let's go with this one here. It's hard to see this one here, but this is 1 meter equal 100 centimeter. Just that part. Okay.
Oh, okay, I see it.
Yeah, so 1 meter equal 100 centimeters. Okay. So you see, this appears twice. Yard, yard. Meters appears twice. Meters, meters. Centimeters appears twice. Centimeters, centimeters. So I should be good. Now I can start my math, okay? So I start with the given number and the unit. 1405 centimeters. I draw my conversion bracket. Okay, so I just use this. I'm done. Now, because this is centimeters, what I write down here has to have the centimeter unit. So which equality, this is called the equality, which equality can I pick next that has centimeter in it? Only one has that.
The bottom
Do you
one.
see this bottom one here?
F-
And then remember, the
yeah, that
100
one.
goes with
Mm-hmm.
centimeters, right? So I write 100 here because it's part of centimeters. Then these go together, so the top has to be 1 meter. I just use that equality. Centimeter and centimeter cancel out. Now the next dominant unit that drives my next move is meters. So which equality can I pick that has meters in it? I don't really have options, right? This one is the only one available with meters in it. I only have one, so I can't really pick. I have to use that. But remember the meter has to be on the bottom because they have to match diagonally. So I put the
Mm-hmm.
0.914 here. And then the 1 yard goes in the top. And that's it. Ta-da! I've used that one. So the question is, am I at yard? Let me cancel the units out. Yep. You want your wanted to be on the top right part. So since my yards, what I'm solving for is in the top right position, I'm done. Now, how do I work the math out? Multiply all the numerator numbers, 1405 times 1, because it's 1 here, times 1. Divide all the denominator numbers. Divide by 100. Divide by 0.914. Oh no, it's 1 4. I pressed that yeah, 1 4. It's not 0.91, 0.14.
Okay. Makes sense.
Okay? So yeah, that's that one.
Mhm.
Okay, so that was the first one. The next one we're gonna be working will be kilograms to ounces, just so you can get a hang of this. So 0.5527 kilograms, and we're going to ounces, OZ. Okay, so what section or what category of measurements is this one here? 0.5527 kilograms to
Volume.
kilograms, not kiloliters, kilogram. You said volume?
Oh wait, no.
Yeah, kg.
Uh, see the
See, what you're doing, you're looking through the units here and you're trying to find kg or OZ. Where is it?
mass,
Mass. Yes.
where the mass is.
Right. So these are mass conversions. Okay. So now you want to tell me what conversion do you think is a good one to use to go from kilograms to OZ, ounce?
Mm,
Now the best one to
would I
pick,
start with the first one?
you can go with the one that has kilogram in it or one that has ounce, but you get to pick whichever. Whatever you pick, I'll work with it. So whatever you pick has to either have kilogram or ounce or both, right? I deliberately wrote this question so it doesn't have
Could
both.
I do the 1 ounce equals 28?
This one here, okay. You could use the first. Oh, were you saying the first one? The first one works. This one works too. So which one do you want to go
Yeah, I
with?
wasn't sure.
Okay, the first one we can adapt. So
Mhm.
there's no one right way. Whatever you pick, you make it work. You could start with this. You could start with that. You could start with this, or start with that. Right? Either one is right.
Okay.
So you want the first one?
Uh,
Okay, let's go with the first one.
which
One
one's
kilo.
easier?
There is no such thing. 1 kilogram equal 1,000. The easier one would have been for me to
I'm just
give you
saying.
one where there is one
Oh.
conversion. Yeah, the first one works. It's easy. So this one is a good choice. 1 kilogram.
Okay.
So this is a kilogram matches a kilogram here. Now you need one that has grams and ounces. So we'll go with the next one you picked, right? I use this first, right? Now this is this other one you use, a 28.5, 28.35. You see that one? That was the second one you actually suggested.
Yeah.
That's a good one because it takes us from grams. So you see, our goal is to go directly from kilograms to ounces, but we can't because there isn't a way using this. So we kind of detour. We go from kilograms to grams, from grams to ounces. So it's kind of like that. Like you're trying to go a direct route, but there's something going on here. We can't go directly, so we go from kilograms to grams, from grams to ounces. So we got, let's see. Yeah, we got this conversion here. That's this, kilograms and grams. Now we got grams and ounces. That would be this one here. 1 OZ equal 28.35. Okay? This next one connects grams and ounces, so that's the best. Okay, so now let's work it out. We start with our number, 0.5527 kilograms. Then you draw your brackets. And then with your brackets here, let's see. Yeah, with the brackets here. Oh, which unit do I pick? Seeing that I have kilograms up here. Which equality do I pick? The top one or the bottom one of these two?
Mm, the top one.
Yeah. Since you have kilogram, you pick the equality that has kilogram in it, right? So this part here has to go on the bottom because that's just how these brackets work. 1 kilogram here, 1,000 grams. And so I just use this. But now kilogram cancels out with this kilogram. Now the dominant unit is this one here. Okay? So my next move, I got to use this one here. Got to write this in the bottom. 28.35 grams. And then 1 OZ right here. This and this. And then am I at OZ? Yes. Okay, great. That's it. So for your
Okay.
math, yeah, you take the top number, multiply all the top numbers times 1,000, divide by all the bottom numbers, 28.35. Then the unit that remains is OZ. So your answer will be in OZ. See, that wasn't that bad. So let me do, let's see. I have these last two, and
Mhm.
then that would pretty much be it. The rest of it, I have done the video and I've posted them. So once again, I have a lot of video that I have posted on there. Take the time before you panic. Ask yourself, has she posted a video about this moment? Most likely. If you're not sure, ask me about it, and I'll tell you there's a video on there. But I usually, because I've been doing this for a while, I know the time, the points where people are going to struggle a little bit, so I try to address that. Okay, this next one, now that we're done with this, next one all the way to the end, is going to be 4.114, because knowing how to select your equality is part of, I want to say the game, but the process, right? So we're going from gallons to cups.
Mhm.
What kind of measurement is this? Gallons and cups. So you want to look at your list. We know it's not time. So just the three that we have here.
Gallons to
Gallons and
cup.
cups. So look around.
Volume.
Volume. Very good. You see how much more confident you're getting, right? So in any question, you're kind of doing the same dance all the time. You're asking yourself, which one is it? Don't waste your time. If you think it's volume, don't waste your time here. If you think it's mass, don't waste your time in volume. You're just fine. Okay. So now I have 4.11. I need something that has gallon in it. Can you find a conversion that has gallon in it?
Let's see.
Or you can find one that has cups in it. Whatever you want. You tell me either cups or gallons. Ooh. What
The
was
1 gallon equals
liters?
8.78 liters.
Okay, give me a moment. What was I thinking? Oh, not bad. Okay. No, for a moment there I was panicking. That's fine. 1 gallon equal 3.785 liters. Because I wanted to make sure whatever I picked, you can work it out with these, right? So you see here, we're not going directly to cups. So it looks like we're detouring. We're going to go from gallon to liters. Now, can we get one from liters to cups? Can you see if there's one from liters to cups, or do we have to go another step? Do you see any conversion that has cups
I
in it?
don't see one.
Oh, okay. Then now we're desperate. Find anyone that has cups. Then we'll work backwards from cups.
Anything with cups?
Yes.
Mm, I don't see anything with cups. Or am I
This is
not
the last
looking
one here.
correctly?
This one here.
Oh, I see it.
Okay, so
Glass.
so it's kind of once again, it's like you're traveling from one place to another, right? Gallon to cup. So we're detouring. We're going from gallons to liters, but I don't see a connection between liters to cups. So I'm gonna work backward. Like we got to cups from 1 pint. So I'm gonna write that conversion here. 1 pint equal to cups. So I'm gonna ask you this: is there a connection between liters and pints?
Mm, liters and pints.
Yeah, or PT and L. Look for PT. That
Okay.
may be easier. Not Q,
Okay.
PT. PT and L.
Mm, hmm, PT. I don't see PT on here. Oh, I see it. The one PT
Yeah,
equals two
yeah,
cups.
yeah. This is our last but one. You're probably
Okay.
getting tired. But this one here, right? So
Oh,
we
I
see
see
a
it.
direct connection from PT. So this was our desired route up here direct, but we couldn't find that. So we detoured. We went from gallon to liters. That's the first conversion here.
Hmm.
From cups to PT, second one. Then from liters to PT, that's the third one. So I'm gonna write here 1 PT equal 0.473 liters. So you see that, right? We didn't have a direct conversion, so instead we used three different conversions, and we'll use it like that. Each conversion helps us to move from one unit to another. The first one will take us from gallon to liters. We'll use this one here from pint to liters second to go from liters to pint. Then we'll use this one here last to go from pint to cups. So since
Mm,
it's a
okay.
since it's a long step, I won't erase that one. I'll just write this on the bottom. So 4.11. I hated this method until I got it and I loved it. I'm like, this is like a game. It's like a puzzle. So we're starting
Yeah.
with gallon. We're right here, right? I'm gonna draw my brackets. Ooh, okay. I'm using my mouse, so it's hard to write with my mouse and make straight lines.
Oh, okay.
So I have my next unit has to have gallon in it because this is gallon, right? So what do you think is my next conversion or my next equality?
Is it like hold on. When would it be one
Yeah,
gallon equals
yeah,
3.758 liters?
yes, 1 gallon. You see, when you pick them out, it's so easy what to pick, right? Because you're only choosing from three versus choosing from all of these. Ooh,
Yeah.
3.785 liters. Okay, gallon, gallon, cancel out. And I like to cross them out so I know what I've used. Okay, next one that's driving my move is liters. Plus, it's like now I'm doing this step here. I'm going from liters to pints. So I need a conversion that has liters and pints, right? Or liters right
Hmm.
here. Of these two, which one has got liters? Just the last one. You see that?
Yeah. Hmm.
So then I put this one point zero. I mean 0.473 liters. Then it goes with 1 pint. Okay, I just use that one. So I'm right here now. I have one more step and I'm right at where I want to be. Step number three, I'm going from pint to cups. I use that. That's all I have left.
Hmm.
The pint part goes down here. 1 pint. Oh, I haven't canceled liters. Liter. And then the 2 cups, 2 cups.
And then you're done.
Yep. See? And that was a harder one. For a moment there, I was like, what did I do? Yep.
Mm,
And I'm done. Now, as
okay.
usual, multiply all the top numbers, divide the bottom one, and then you get your answer. It'll be in the units cups.
So
Okay.
when you mean by divide the bottom number, what's gonna be the bottom number for all if they're all getting canceled out?
Let's see. You multiply the top number 4.114, 3.785. You can leave the one out. Oh no, only the units are being canceled out, not the numbers. So
Oh,
times
okay.
2 divided by the ones you can ignore. Divide by point four.
Oh, okay.
Yes. You cannot just cancel that number out until there's a number just like it in the numerator.
Okay.
Okay? Now, after you're done with this, and you go and actually, I didn't want to work these out for you because it's supposed to be you working this out, but I'm
Yeah,
doing
that's a
for
lot
time.
anyway.
Okay. Now the last one I have here, which will be point. Oh, let me mark this out. 0.75. I'm doing kilometer per hour and we're going to miles per second. Ooh, miles per second. So with this one here, just like before, I want you, first of all, I usually I like to write my complex units that a unit over a unit as a fraction. So I remember this is a fraction. So I'm going to change this number without changing the value over the one on the bottom. Remember, any number divided by one is the same number. Okay. So 0.75 kilometers over one, the same thing as 0.75 kilometers over, yeah, 1 hour. Okay. So please notice here, these top numbers are similar in the type of units. So what type of measurement do you think the top number is? Kilometer and miles. I highlighted them so you can separate them. Kilometer and miles is what type of measurement? Let's go back here. It's not time, right? So it's either length, mass, or volume. What do you think it is? Kilometers and miles. You hear me? Hello? Okay, let me make sure that this is not. Oh, wait. Are you there? Oh, you can hear me. Okay, okay, that works. Oh, your phone died. Okay, okay, fine, fine. Let me go ahead. Then, yeah. Let me try. Okay, that works. So what I'm gonna do then, I'm gonna put this here. Ah, that's okay. I can be flexible. I'm gonna put this here because now we're gonna be chatting. And then let me try to find my conversion. So what kind of measurement do you think the kilometers to miles is? So I'll say based on this right here is a length, right? So you want to go through and find a length conversion that actually works with kilometers and miles. So I'm going to look for here, kilometers, this is meters, not miles. I'm going to look for kilometers, none here. Oh, there it is, 1 mile. Yes, very good. So one mile is 1,609 kilometers. Now is that 1 point? It's 1 point. This is 1 point. Yeah, it's not comma. I was wondering about that. Yeah, this is 1.609 kilometers. Okay, so I got the conversion for the top part. Now for the bottom part, this is a time conversion, so it's not here. So I want this chart does not have time conversion. So I'm gonna pull this out here. Pull this out. Come on. Hold on. Let me make this bigger so I can have more room. There, and then pull this to the left. Yeah. So let me see here. Yeah, the bottom one, it is a time conversion, so it's not here. So what we're gonna do is let's go through the time and then make it smaller, 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 starting with 1 hour. So 1 hour is what? 60 minutes, right? And that's a smaller unit. And then the 1 minute is 60 seconds. So that actually works. So for hour, we're not going directly to seconds. We're going from hour to minutes to second. Okay, so hour to minute to second. But the top part, we go directly from kilometers to miles in one conversion. Okay, that's our plan. So I'm going to write this out. 0.75 kilometers. Again, I draw, ooh, this is supposed to be a horizontal line there. Now, which unit? Oh, sorry, 1 hour. I forgot the bottom part. 1 hour. So 0.75 kilometers is the top part. The bottom part is 1 hour. Let me make this a little better. It's hard to draw that line with my mouse. My hand doesn't go steady. Hold on. Maybe it'll be better if I bring my hand nearby. Oh, my mouse just runs into different things. Anyway, there it is. So, you know what? Let's convert the kilometers first. Let's do the length first, then we'll do the hours. So we'll start with the top right here. Okay? That means if it's kilometers here, it must be kilometer on the bottom, right? So of the 3 units, which one do we use? Of course, you want to use the one that has the kilometer in it, right? So the top one has a kilometer in it. So that will be 1.609 kilometer on the bottom, and then 1 mile on the top. Okay? So I use this one because this one was driving my move. Kilometer cancels out. I have the top one done. Now I have to convert the bottom one. But remember, we're not going directly because we didn't find one. We're going from hour to minute, minute to second. Okay. Now we're trying to convert the bottom part, just like the top part. To get rid of this unit, we have to get another unit directly across. Well, not directly, but it has to be diagonally across, like right here. There has to be some number here with the unit HR. So I go through here. Can I find some hours? Wait, right here. This one works. So I put the HR part on the top. One HR has to go with this. And on the bottom, I put 60 minutes. See? The good thing about dimension analysis, you're letting the units drive what you're doing. So your moves can be different and unpredictable because of the unit that's present, right? And where it's located. So now hour and hour cancels out. I have minute on the bottom, but I have one more move, right? I use this one here. Now I have to take minute to second, so I have to put 1 minute up here and then 60 seconds on the bottom. So just like before, minute cancels out. As long as they diagonally match, the units cancel out. Only the units are canceling out, right? So let me see. Maybe can I open the next page? Ooh, took me back. Trying to see. Okay, so as far as this is concerned, as far as the math is concerned, let me erase this so I can do my math right here. So I'm multiplying all the numerator and then dividing the denominator. Okay, this is gonna be point. Ooh, come on, right? Okay, so multiply all the top parts. 0.75, that number, times 1 times 1 times 1. All the top numbers divided by all the bottom numbers. 1. You can leave the ones out. Wait, hold on a second. You're saying so they can be in a separate order as long as. Yes, very good question. They can be in a separate order as long as they're diagonal. They don't have to be next to each other, but they have to be diagonal for them to cancel. That means the HR doesn't have to be here, right? That's what you mean, right? But if they're diagonal, they're canceling. Yeah. So you're looking everywhere. It's like this and this cancel, this and this cancel. Yeah. They don't have to be next to each other. Very good question. Okay, where was I? So all the top, that times that times that times that, divided by the bottom, divided by 1.609, divided by 60, divided by 60. I'm trying to write smaller. And all of these, when you do your answer, you have them in the unit. This did not cancel out. Remember that this unit did not cancel out, and neither did this unit right here. So the units that remain will be written in the proper position. So the Mi will be on top because that's where it is right now, and then the S will be on the bottom. So once you do all your math, multiply all the top ones, divide all the bottom ones, whatever number you get, the unit is miles per second, and that's it. So this method will help you solve for your lab problems. Now your lab problems will not be as complex. Some of them will be even simpler, but yeah. Dimension analysis is frustrating until you figure it out that it's actually not that bad. Okay? But yeah, that's it for that lab. Do you have any additional questions? Now, we didn't do the actual lab. We just did very similar ones, right? Okay. Is your phone alive again? Okay. Well, okay. Well, if that's it, this is all I have for right now. So once again, we'll have a session on Tuesday and Thursday in the morning at 9:30. If you can join us, great. If you can't join us, what I'm gonna do is I'm gonna be posting the videos because people are kind of not staying the whole lesson. It makes it hard for me to teach when there's nobody there. I'm gonna post my old videos and then I'll just answer questions and deal with specific parts. Okay? So it'll be less of a lecture and more problem solving. But yeah. Yeah, that's all I have. If you don't have any more questions. Uh, you can get it done by tomorrow, right? Yeah, you don't want to wait till too long because the next week you have a different lab. Yeah. You can work on the other one. Try to get by tomorrow, if not tomorrow, Tuesday, so you're not falling too much behind. Okay. Yes. Any other question? Okay, you're welcome. Have a nice evening. Okay, bye. Oh, you can't see me. That's okay. Bye. Good night. Okay, let me stop the recording.